Hi, we are TechData-Academy, and in this video we will explore Kubernetes to Prometheus to Grafana, debugging failed pods in Minikube. Minikube starts using the Docker driver with 4 CPUs and 4 GB of memory. An existing profile is detected and the Docker container is restarted. Kubernetes v 1.34 is prepared on Docker 28.4.0. Core components are verified, including metrics server, ingress nginx, dashboard, storage provisioner, and webhook cert generator. Ingress verification completes. All add-ons are enabled. kubectl is configured for the Minikube cluster and default namespace. 8 namespaces are active in the cluster: default, e-commerce, ingress nginx, kube node lease, kube public, kube system, Kubernetes dashboard, and monitoring. The full pod list across all namespaces appears. Most pods are running, but several are failing. Crash loop backoff and error states are visible in default and e-commerce namespaces. Filtering for failures isolates 3 critical pods. Filtering all namespaces for failures shows crash-pod 2 in crash loop backoff with over 3,000 restarts, crash-pod in error, and crash loop pod in crash loop backoff. Describing crash-pod 2 reveals a container running nginx 1.25 Alpine with a command set to false. It exits immediately with error code 1. The restart count is 3,123. The event section shows the kubelay applying backoff restarts 351 times over 77 minutes. Checking the container logs returns no output. Checking previous logs also returns nothing. Prometheus is exposed via port forward on port 9090. The connection is established on localhost. Querying the metric that tracks container restart counts for crash-pod 2, returns an active series from kube-state-metrics confirming ongoing restart tracking in the default namespace. Running a query that computes restart rate over the last 5 minutes returns 2 active series, crash loop-pod in e-commerce and crash-pod 2 in default. We start by forwarding the Grafana service to our local machine. In the terminal, run kubectl port forward, namespace monitoring, service Prometheus Grafana port 3000. Open your browser and go to localhost :3000. Grafana loads. In the left sidebar, click Dashboards, then Import. The import panel opens on the right. Enter the ID 15760, click Load. The dashboard template is fetched from the Grafana library automatically. Select Prometheus as data source, click Import. The Kubernetes dashboard appears with all pre-built panels already populated. Click Edit to enter edit mode, click Add Visualization. A new empty panel opens. At the top, enter the panel title, number of restarts of pods. In the PromQL field, type sort desk, kubepod container status restarts total, greater than 100. This retrieves the total restart count for every container in the cluster. The greater than 100 threshold filters out healthy pods that restarted only during normal Minikube reboots. Only pods with real crash problems remain visible. Scroll down to options below the query. In the legend field, type double curly braces namespace / double curly braces pod. Each bar is now labeled with the namespace and the pod name together. Open the Transform Data tab. Click Add Transformation, choose Reduce, set mode to series to rows and calculation to last. Without this, Grafana plots every data point over time. With Reduce Last, each pod gets exactly one value, its current restart count. Switch the visualization type to bar chart. The graph now shows only pods with more than 100 restarts. Crash-pod 2 and crash loop-pod immediately stand out at the top with thousands of restarts. To focus only on the most critical pods, change the threshold from 100 to 1000. Now only crash-pod 2 and crash loop-pod remain. Click Save Dashboard. Your custom panel is now saved permanently inside the Kubernetes dashboard. Reopen Dashboards. Your new panel appears alongside all the pre-built Kubernetes visualizations. Same dashboard, same Prometheus source, same data. kubectl detects the crash. Prometheus measures it. Grafana visualizes it. One metric, 3 tools.